So problem 35 from chapter 13. If 25 moles of helium gas at 10 Celsius Can we be silent? Silent. Silent. 25 moles of helium gas. Now, by the way, just a little bit of trivia here. Okay. Do we need to know that it's helium? No, because they told us the moles. Now, if they later ask how many kilograms of gas we have, then I think we need to know helium, but probably not for this problem, right? Is at a gauge pressure of 0.350 atmospheres, so the gauge pressure is 0.350, right? So that means, by the way, that its real pressure is plus 1 atmosphere, right? Because this is how much more than an atmosphere it is. So the real pressure is 1.35. Does that make sense? If your gauge pressure is 0.1 atmosphere, your real pressure is 1.1. Yeah? If your gauge pressure is 0.35, then your real pressure is 1.35. What if you have a gauge pressure of negative 0.2 atmospheres? You can have negative gauge pressures, right? That means that your real pressure is 0.8, right? Of absolute pressure, right? So then I'm going to go times 1.013 times 10 to the 5th pascals. Why am I doing that? Because I have to do the ideal gas law using like physics, right? Using the physics one. And then we want to know the volume of the helium gas. So V is the thing we won't know, right? N is 25.50. R is always 8.31, right? And then temperature is, what do they say? Oh, it's at 10 Celsius, right? Is that the real temperature? No, it's just T. It's a T all by itself. You have to use the real temperature. So it's 273.15 plus 10 is 283, right? And so it seems like if we use this for our pressure, this for our N, this for this, right? The V is just going to be, what is it going to be? nRT over P. So I won't insult your intelligence by throwing the numbers in, because I'm pretty sure we'll get the right answer, right? But then the second question says, for 35, it says, what is the temperature if the gas is compressed to precisely half the volume at a gauge pressure of 1 atmosphere? Now, we can do that using this volume, but can't we do a combined gas law sort of thing and not even use the answer to that problem? I think we can, can't we? Right? I think we can do one of these, can't we? Yeah. For that. So let's set that up, because that's the more exciting thing, right? So this is part A, right? And then part B, I think we can do PV over NT is PV over NT. Why do I have a bad pen? And what happened to my good pen? Oh, here it is. What happened to my good pen? So in the original condition, we were at 1.35 atmospheres. V I don't really care about because it'll be, oh wait, I do care about it, but we're going from V to half of V, right? N is going to still be just N. The N doesn't change, right? T is 283.15. Isn't that our original condition? Right? Now I could put the volume that I calculated there, but don't they tell us that it's half the volume in the next part? Right? So it's going to be 2 atmospheres. They say 1 atmosphere of gauge pressure. Doesn't that make the real pressure 2 atmospheres? Yes? Right? And then the V is just the same V. Oh wait, no, it's half the volume, right? Right? And then N is the same N. That's the thing that's the same. And then T is what we're solving for. Isn't that right? Seems like we ought to be able to solve this, yes? Boom. Boom. Those go the way of the bison. You ought to be able to solve that for T. Is the answer, let's just make sure we have the right answer. For the second part, the answer should be 283.15 times 2 divided by 1.35. Times 0.5. Is the answer 209 kelvins?
Hold on. Yeah, 209.74.
Okay, is that the right answer? Okay. How about 36? Are we okay on 36?
That's what I got. So it must be right.
That's what you got? Did you check the answer in the back of the book?
No.
Let's check the answer.